Okay, now we will be discussing about the unit 1.2 of solar panel installation. So unit 1.2 covers renewable energy and solar energy system. So now a very brief overview to the renewable energy. So first of all, why we are needing the renewable energy? Because currently the most of the energy requirement of the whole world that is being fulfilled by the fossil fuels. So that includes diesel, petrol, coal, LPG, CNG. Okay, now what are the issues related with these fossil fuels? One is from the environment point of view that the emissions which are coming from this type of fossil fuels, they are affecting the environment, like the air quality that is degrading. Okay, another issue related with this fossil fuel is the either limited supply, because maybe currently we are getting a good supply of these fossil fuels, but in the future they will be exhausted. So our need is to search for clean and long lasting sources for energy. So a few of these such sources are shown here, like the wind energy, solar energy, hydro energy, biomass energy. So what is wind energy doing? It is transforming the kinetic energy of wind into electricity. And solar energy, so what the system is doing, it is converting solar radiation into electrical energy. Okay, then next, the hydro energy. So energy that is present in water flow. So this is the kinetic energy, because water is flowing from a high level to a low level. So there is a kinetic energy there. So this energy is utilized for generating or converting this energy into electricity. Then another one is the biomass energy. So biomass, basically that could be plant, like animal, some organic matter. So energy present in this biomass that is converted into other form of energy which we can utilize. So not only electricity, it could be converted into biogas, okay, biofuels. So all of these sources, they are renewable, means they are long lasting. Their usage that is having a minimum impact on the environment. Now coming to the solar energy. So solar energy that is basically coming from the sun. Okay, so these are in the form of electromagnetic radiations. So when this energy is converted into different form of energy which we can utilize for our purposes, like we can use it for heat, we can use it for generating electricity. Okay, so when the solar radiation they reach the earth, okay, then some of the energy that is reflected back, and some of the energy that gets absorbed in the atmosphere, some energy reaches earth's surface without any conversion. So it is converted into wind energy and biomass energy. What does that means? That basically wind and biomass energy are indirect form of solar energy. Okay, and this energy is used in water evaporation. So this causes rain. Okay, and it is available in the form of hydro energy. Means all of these other forms of energy which we studied, they are related to solar energy. Okay, so amount of energy which is reaching the earth, that is much higher as what we are obtaining from fossil fuels. Means we can efficiently collect it, harness it, then we can fulfill most of our energy requirements. Okay, so in 2013, the annual energy consumption from all possible sources, including electricity, coal, gas, diesel, petrol, biomass, that was 567 exajoules, or 1,57,481 terawatt hours. Okay, whereas the total electricity consumption was 19,504 terawatt hours. And on the other hand, the solar energy available, that was 38,50,000 exajoules. So it is about many thousand times more than the annually consumed energy. Okay, so it means there's a huge amount of energy which is available from sun. So we just need to collect it. We just need to efficiently convert it into our some suitable form which we can use, which we can exploit as per our requirements. Okay, now some of the commonly used units: power, that is watt, then kilowatt, megawatt, and then gigawatt. So larger, more the larger the units. Okay, now standard energy, a unit of energy, that is joule. So here it is a conversion from joule to watt second. Okay, so 1 joule, 1 watt second. Now converting it to watt hour, we have multiplied it by the seconds in 1 hour, then kilowatt hour. So this 1 kilowatt hour, that is the standard unit of electricity. Okay, power, as we have studied in the previous chapter, that what is energy? It is power multiplied by the time period. So 1 kilowatt hour, so 1 kilo, the kilowatt, that is the power, and 1 hour, that is the time. Okay, now the solar energy system. Okay, so solar radiation available, that depends from one location to the another location. So on an average in India, about 4 to 7 kilowatt hour per meter square energy is received in 1 day. So that is a good amount. In 1 meter square area, we are receiving this much amount of this energy from the sun. Okay, so it depends at how much we use our solar energy system to utilize this available energy from the sun. Okay, so the solar power system, how it works? So the solar radiation hits the solar cell and gets transformed into DC energy. DC, okay, we have discussed, energy we have discussed. So solar and radiation, that is transformed into DC energy by solar cells. How they convert, we will study in our coming chapters. Okay, then the DC energy is converted into AC with the help of an inverter. Then the generated AC and electricity is identical to the power that is provided by the utility companies. Okay, with a similar energy which we are getting from the electricity main, from the electricity board. Okay, so the AC electricity can be supplied to gadgets, commonly used household gadgets, computers, lights. Okay, directly they can be utilized. The electricity generated can also be transmitted to the national electricity grid, and from there it may be supplied to all over the country. Means using solar cells, we are generating electricity and then we are supplying it back to the grid. Means we are feeding it back to the grid. So the power transfer is two-sided, from grid to load and from load to grid as well. Okay, so in brief, uh, how this system is working. Here it in the diagram we can see from sun, the light that is coming to the solar cells. From there it is being fed to the load and it can also be fed to the grid. Means what do we need here? First of all, we need a solar then further we can use electricity for our to running our different type of loads. Okay, now just a brief introduction to these different components. So solar energy system, or a PV. PV stands for photovoltaic, light to voltage. So solar energy system or a PV system is a power circuit device to supply the available solar power in the form of electricity. So in this system, the solar panel is the main component because this is the component which is converting light into electricity. So it is constructed in such a manner that it absorbs the sunlight as an energy source and uses it to supply electricity or provide heating. It's not only electricity, we can also obtain heat energy from sun. Okay, solar panel has to be placed in the sun to generate electricity. Okay, it is very simple to use. Okay, but it is expensive. Okay, so how so the solar panel consists of a basic unit, that is solar cell or PV cell, photovoltaic cell. So what is it? It is made up of silicon, similar to the silicon used in computer chips. Okay, so the PV cell is made of two types of silicon. So what are the two types? Monocrystalline and polycrystalline. When these two silicon receive solar energy, they develop a voltage difference, okay, potential difference across themselves. So as there is a potential difference, this will cause a flow of current from higher potential to the lower potential. Okay, and these different solar cells, they combine, fitted in a frame, and they form a solar panel. Okay, so two type of silicon, monocrystalline and polycrystalline. In the diagram, we can see the different components, how they are made. So the solar cells are there, encapsulated up and down, then glass, then frame, then a backsheet on the backside, and a junction box where the wires are connected. So light is falling through the glass to the encapsulant to the solar cell. From there, it is converting the light into electricity. Then that is being extracted using the junction box. Components which are being used in a solar power system or a solar photovoltaic system. So battery, why we need it, I will just cover. Battery, very common to the battery used for other purposes, used with in a UPS as well, we can see. So what are they doing? They are basically storing the light. So why do we need to store the light? We need to store store the electricity because it is not available every time. Solar energy during night it is not available. Now we want electricity. We need to run our lights, fans, other type of load during night. In the absence of solar energy, then we will be needing a battery. So in the daytime, solar panels, they're generating electricity and it is stored in the battery. So battery is charged. Now during night time, the battery that is giving electricity to the load. Okay, now the sunlight, that is more sunlight is coming, that is resulting in a larger number of charge or the current or the voltage to be generated by the solar panels. This has to be in limit with the range of the battery, so that is controlled by using a charge controller. Okay, so charge controllers, they are regulators, okay, which control the DC output and deliver that to the grid, the battery or load. Okay, and they ensure smooth operation of the PV system. Next is the inverter. So inverter, okay, it is used for converting DC into AC because the load that is mostly it is AC. If our load is DC, then we don't need an inverter. Okay, now the mounting structures. So they are required to fix the PV modules and to ensure that the modules are directed towards the sun. Okay, because only if they are directed towards the sun, then they will be able to generate maximum energy. So load, they are the appliances which are consuming the power which is generated by the solar PV system. So here in the diagram, the same type of energy conversion and the components used, they are shown here. So from solar energy to solar panel to charge controller to battery. From battery, the two paths are shown. First one is to the DC load. Next one is through an inverter and then to a AC load. Means if the load is DC, we don't need any inverter. Directly we can connect it to the battery. Whereas if the load is AC, then we do need a inverter. Now the types of solar energy system. So three type of solar energy systems, they're available or they are being used. First one is standalone and next one is grid connected and the third one is hybrid. We will discuss each one of them one by one. So standalone solar PV system. Okay, so whenever system is called a standalone, when it is not connected to any other source or to the grid, we can say, means it is not receiving any type of electricity nor it is selling any, supplying any electricity back to the grid. Okay, in case of a standalone system, the battery, they are needed. Okay, because as I just said that during the absence of solar availability, our system, the load, it needs energy, so it has to be supplied by the battery. Here in the diagram, an standalone system that is being shown. Solar panel, from there It's connected to the charge controller, from there the battery, okay, and from there the inverter into the AC appliances. These AC appliances, they are installed inside the house. Next one is the grid connected solar PV system. So this type of solar PV system that is connected to the grid means it can receive power from the grid as well, or it can supply power back to the grid as well. Here in this case, we of a grid connected solar PV system, we do not need a battery. Here is the diagram. Why we do not need a battery? Because in the absence of solar energy, we can directly take energy from the grid. It is connected to the grid as well. Okay, so during the solar availability, power that can be generated, it can be supplied to the electricity grid. Okay, in case we need electricity during the absence of the solar availability, during in the absence of the sunlight, like in the night time, then we can take energy from the grid. Next is hybrid solar PV system. Okay, now let us say that we want a good amount of energy, we want to generate it, but our solar PV system is not having that much of capacity, it is not having that much of power level that it can generate whole of the electricity which is being needed. So in that case, some other sources of generation that are also used. So very common is the diesel generator. If we want electricity during daytime, okay, we are getting it from the solar panel, from the solar system. Okay, whereas we need even more energy. Okay, we don't have that much of space to install solar panels to generate a very large amount of energy. In that case, we will run the diesel generator. If our requirement is fulfilled by the solar panel, okay, we don't need to run the generator. But if it is more, then we will run the diesel generator. So this system is having usually two or more sources of energy. And most commonly, this type of combination in a hybrid power system consists of one renewable energy resource and one non-renewable energy resource. Here in the diagram it is shown. So wind turbine system we are also using. Okay, we are using solar panel system along with the solar panel. There is a wind system also. So we can say it is a hybrid. Means it is having more than one. Solar is there, wind is also there. So two type of resources we are using. From here we can conclude the different advantages and disadvantages of solar energy system. The biggest advantage, it is clean, non-polluting, doesn't has any adverse effect on the environment. Next, it is renewable. It can be used again and again. Third one, no type of noise is produced. Because in case of a generator's diesel engine and this type of systems, noise is produced. Okay, next is very less maintenance is needed because a static device, just keep it and let it be there. Yes, some minor maintenance could be like we need to clean it. Dust is falling on it then. Okay, next they are very long lasting. Okay, they have a very long life. Okay, then they can be used anywhere. Almost all of the locations we can install our solar panels. Then no fuel cost. Okay, like a diesel generator. As diesel generator, we need diesel to run that generator. So diesel is the fuel, the cost of that diesel. We have to pay that. But in case of solar panel, we don't need to pay for any type of fuel. Okay, now coming to the disadvantages. The solar power we cannot get in the night because sun is not available there. Okay, next thing, they are expensive. Cost is high for the solar panels. Third, we need a storage device like a battery so as to get power as and when required. Okay, next is air pollution and the weather can affect the production of electricity. We will discuss it, how weather is going to affect it. Pollution is also one of the reason which reduces the electricity produced, because then if the during pollution the dust and dirt that accumulates on the surface of the solar panel, that reduces the light reaching the solar cells. Okay, next thing, they need a large area of land to produce efficient power supply. Yes, land we require where we need to put our solar panels. Okay, then small activity question answers. Renewable energy resources, just we have discussed. Three demerits of solar energy, we have also discussed. Solar energy conversion process, that also we have discussed. Okay, so I shall stop here now.